really bad, then they won't know. And if it's really good, then they'll just hear about it and feel bad. So, it works out pretty well for me either way. Go ahead and start.
Sorry, I was thinking back outside. I just wanted to introduce myself.
Okay.
Probably everyone knows you, so.
Okay, so hopefully you have a nice lunch out there. And now we're ready for more presentation. Again, a long rally today. And I'm glad that I could get again Matthew, the lead developer of Asterisk. A long trip for them as usual, and they are also supporting the event. They have here some nice phones that maybe you would like to check. David is around, and another Matt can help you with insights of what goodies they can provide with the APIs for the phones. And again, Matthew, thank you. And let's see with the presentation and the architecture what's to reveal.
All right, thanks, Daniel. Matt Jordan, Director of Technology at Digium. I'll be talking today about the architecture of Asterisk 13. And when I talk about, when I put together the talk proposal for this Kamailio world, I decided, looking back at Asterisk 12, which is really the first version of Asterisk that contained a lot of these new major features that I've been talking about for a couple years now. It contained a new SIP stack based on the PJ SIP library. Contained a large number of new APIs, including the Asterisk REST interface. But behind all of this is a new core and a new architecture that enabled all of these new features. And in the previous iterations of Kamailio world, I talked about the PJ SIP stack, talked about Asterisk APIs and ARI, and so it felt appropriate that it was time to actually talk about this architecture that these things are built upon. After this year, I'm going to actually have to come up with a new topic. I'll be out of things to talk about, and so I'm going to have to start looking for new material. So let's talk about some C APIs. Everybody's excited about it. Let's look at some C code, right? Tori raises his hand. He enjoys that. I'm going to put you all to sleep if I do that. So I'm not going to actually talk much about the APIs themselves. What I'm going to talk about is, in particular, one framework and one section of the core that we focused on. There were other core architectural changes made, but this is probably the big one and the most important one, and it's bridging. This is, by the way, the Mackinac Bridge in my home state of Michigan, 8 kilometers long, which is about the size of the bridging framework as well in Asterisk. So in Asterisk 13, or 12 really is where it started, we redid all of the bridging in all of Asterisk. Every call that you make, every channel that gets bridged is using completely new code than what existed previously. That's a little bit of a stretch. It's not completely new, as we'll get into. We did reuse some certain things, but a lot of it changed over time. So the problem, right? How do I justify to my bosses spending 10 man-years to go redo the core of Asterisk, hopefully in a way that nobody even notices? So we're not even talking about features at this point. I'm going to go burn years of development time to go do something that I hope nobody can tell that we changed anything. So why bother doing this in the first place? And it all really starts with Asterisk's threading model. Unlike Kamailio, Asterisk is multi-threaded, not multi-process. I kind of think that maybe Kamailio made a good decision there. So to answer that question earlier, don't do multi-threading. Asterisk, though, has a very conservative threading model. I use that term loosely. It's kind of conservative and kind of not. It's conservative in that each channel gets its own PBX thread, or its own thread to manage that channel while it's being executed. On the other hand, we also use that same thread to service an outbound channel. And so when you make a call, there's one thread servicing both of those channels. And that's why it's sort of conservative. It's not really conservative in the sense that you might have 300 threads running 300 channels or 1,000 or whatever else. But it's conservative that we try to reuse them for the outbound channels. And that was a really good decision, possibly, when Asterisk first got off the ground. Turns out that was actually a really bad decision. Because how do you move channels out of the call? I've got this thread servicing 2 channels, and you have to move channels out of this call all the time. Blind transfers, attended transfers happening either from channel drivers or from the core, externally initiated redirects through APIs, parking. When I go pick up a call out of parking, I've got to pull it off of that thread. Anytime we do call pickup. So anything interesting that happens breaks this threading model is really what it boils down to. And so our solution to this was the dreaded masquerade. Anybody know what a masquerade is in Asterisk? Have you ever run into this? Okay, so for everybody who doesn't, I'm going to blow through these slides as fast as possible. I just want to convey how terrible this is. That's all I'm really going for here. All right, so I've got a PBX thread and I've got my SIP monitor thread, and my PBX thread is servicing both of these channels. And this channel really comes in two parts. There's the SIP PVT, which is the private data structure that's maintaining all of the SIP information, and that actually is doing all the interesting bits of sending SIP messages out to your client, along with the AST channel, which is the part that Asterisk knows about in the core. And there's a little pointer that sort of keeps these things related. And so let's say I want to get SIP bar out of here, and I want to pull him off of the call for some reason. So the first thing I have to do is I have to lock the world. I have to lock all 4 of these objects, and I've got to keep all the threads from mucking around with them while I go do this operation. Needless to say, this right off the bat, if you don't become intimately familiar with the locking order in Asterisk, is a very quick and easy way to deadlock your system. So my first step is I make a new channel. I'm going to call it SIP bar 3. It's going to go off to bar, but it doesn't have a SIP it actually kind of has a SIP PVT, but we'll ignore that point. But I'm about to do something really terrible to these guys. And the first thing I do is I rename him. And I tag him with this name of Mask, which says he's about to be masqueraded. And then I take the one that I'm going to kill and I call it a zombie. So I just renamed him to Zombie. And then I renamed this guy again, so now he took the name of the previous name of the zombie. And then I move the SIP PVT off of the zombie channel up to the new channel that's going to be replacing him. And he's not on any thread yet. I kill the zombie channel, unlock everything, and then assign a new PBX thread and get it off and going. This is not fine. Why is this not fine? Okay, so there's a masquerade and there's this really gross stuff that happens in Asterisk, but who really cares, right? It's all under the hood. It's not under the hood. That's the problem. We exposed all of these operations through the APIs, and if you're trying to build a system on top of Asterisk, you now have to reinterpret all of these channel names and all these renaming events. And then I get this masquerade at the end that told me my zombie went away, but I have no idea why any of this happened. This could have been a parking pickup. This could have been call pickup. This could have been an intended transfer.
The best part is you get hang-ups on the zombie channel.
Yes.
Without the call getting hung up.
Yes, that also can happen. It's just good times. So yeah, you're sitting in fire and your arm's starting to melt off. And so let's go change this, right? So if I actually walk through the code in Asterisk 11 and prior versions, most bridges would start off in a file called features in AST do bridge. Then it goes into the channel core to channel bridge. And if it was a native bridge, we'd then call into the chan SIP. And we'd call into its bridge callback, which goes into the RTP engine, which calls AST RTP instance bridge, which goes into the RTP implementation to actually do a local packet-to-packet bridge. So I've got 5 different layers of code here. And at any point in time, either one of the channels that they're operating on can get nuked out from underneath it and pulled and ripped away. Just willy-nilly, right? What makes this even worse is that all of the stuff that you care about happens interleaved through all of this stack. I've got DTMF features in features.c along with my CDR, CEL, and AMI code. I've got more features that are sitting in the channel code along with format capability checks, bridge timers, RTP source timeouts. Hey, it did the flashy thing. All right, it's back. I've got my RTP compatibility checks happening in the RTP engine. And this is why this code is really hard to maintain and fix or do anything, because it was all sort of not just the bridging code, but all the things that bridging would touch and impact was all sprinkled in through all of this stuff. And at this point, your face melts off. So it's not fine. So this is why we decided to go fix this, because we wanted to provide a stable channel in Asterisk, period. No rename events, no masquerade events, a predictable lifetime for the entire time of that channel. However, we also knew that we wanted to get this done within our lifetime. If we decided to completely rewrite Asterisk from scratch, which is just about what we're talking about here, we would never have actually gotten it done. So we're not going to fundamentally change the fact that Asterisk is multi-threaded. We're not going to change the fact that you must have a PBX thread that services the channel. If we had changed that, we would have broken everybody, and it's just not worth doing. Might as well start from scratch. So finally, we wanted to use existing APIs to maximize the fact that we're going to actually succeed in this. Way back in, I believe, 1.6.1, Wolf wrote the original incarnation of the bridging framework, and then it languished there for about 5 years. So we're like, okay, we're going to start with the bridging framework. That's a good place to start. We were already using it in ConfBridge and Asterisk 10, and we're going to then try to limit how far we go with this, because once you start tackling this pile of code, you're going to end up touching just about everything, which we did. So first step is let's make the bridge an object. Let's start using the framework. So bridges, the way the bridging framework works is it actually has something that maintains the state of the call as opposed to having these two channels just sitting together kind of talking to each other. And that bridge manages all the transitions of the channels coming into and out of the bridge. One of the things that's really cool about Asterisk, and I think this is pretty innovative and novel what we do, I'm sure there's some other projects that do this, but I still think this is pretty cool. Bridges don't determine how the media is mixed. They're merely maintaining the state of things. Instead, we use a strategy pattern, and we actually pick and choose the mixing technology based on the properties of the channels that are in the bridge at that point in time. That lets this be very, very flexible. As it turns out, near the end of the talk, you're going to see how this sort of backfires on us as well, but it's still pretty awesome. So initially we had 3 mixing technologies. We had soft mix, which does the multi-party mixing, simple, which does 2-party mixing where the media is flowing through the core, and multiplex, which was a very sort of weird thing where it could actually manage in a single bridge multiple 2-party bridges. That was really weird, so we killed it, which ended up being a really good decision in the end. And the most important bit is that you do get it when you're in a bridge, you get a dedicated thread per channel, and that lets us not have to do sort of the masquerade shenaniganry that I just showed. I'm going to skip past the C API. The only thing I would take away from this is that you have nice little functions that actually do your blind and attended transfers, so now channel drivers don't have to implement this code themselves. They just simply say, please, I have a refer request. Go do the attended transfer for me, and the core takes care of it for you, which is nice. So what does it look like now as opposed to the previous picture? If I have foo and, well, it really should have been bar, but that's okay. So I have 2 channels sitting in a bridge together. This was my inbound channel, so he had a PBX thread. When this channel was put into the bridge, he got his own bridge thread, and we have 2 threads servicing them. If I decide I want to get rid of this channel and send it off into the dial plan, I set on PJSIP foo, I want to send you off to the dial plan location default S1. I kick you, it sets where he's going to go when he gets ejected out of the bridge. I kick him out of the bridge, and the bridging framework says, oh, you need a PBX now because you're going onto the PBX, and off you go out of the bridge very safely. Well, the nice thing about this is that this lets us present a model of the world to outside parties through various APIs that is very sane and consistent. So rather than having all these renames and masquerades and all this other stuff that happens, you get clear and consistent events about when your channels enter into the bridge and when they leave the bridge. And so the best quote I've heard is there was a developer who told me that he took his system, rewrote it for Asterisk 13, and he's like, I got to delete all my code, and it was an exercise in typing to rebuild it. And that's about as, that let me know I think we succeeded. This is where the architecture started, though. So we have a bridge. It owns a technology. The technology contains various callbacks that tell about what it actually does. And we have 2 implementations of that technology, simple and soft mix. And you say, but what about native bridging? All right, we'll add back in native bridging. So we're not going to rewrite resrtp asterisk just yet, so now we're on to version 2. So we put in little facades over resrtp asterisk and over some of parts of Chan Dotty in order to provide native bridging in Dotty and native bridging in RTP asterisk. And so, okay, now the bridging framework, because these are just different ways of doing bridging again, they inspect their channels, they see if it's a local or remote packet-to-packet bridge, and they move on, and everything's great. So what this looks like, for example, say I've got PJSIP foo and it joins a bridge. So I start off with the simple bridging technology because we don't have a better one to pick yet. A Dotty channel joins, and now I stay in simple bridging because I've got 2 channels. PJSIP Yak joins, and I switch to soft mix because now it's a multi-party mixing bridge, and so I start mixing between those 3 channels. Dotty leaves, great, so I switch to a native RTP bridge, and because Yak may be behind a NAT, I decide, well, I'm going to just do packet-to-packet bridging, and so it switches to that. I'd throw another PJSIP channel in there, and it switches to soft mix. We go back to multi-party. PJSIP Yak leaves, and hey, maybe bar is in the same network as foo, so we switch to a direct media bridge, and we remote packet everybody. So you say, okay, what about my features? I want to hit DTMF keys. We're like, all right, fine. We'll add features back in. So to do that, we create a new object called a bridge channel, and this sort of manages the features that are sitting on top of an AST channel. And it contains containers that contain all your DTMF hooks, interval hooks, and we call other hooks, which were things that didn't fit into either pile. And you can actually add these now on as pluggable modules into Asterisk. So all of your loadable modules now contain the features, and they can actually be extended and enhanced upon as well. So if you wanted some new crazy feature, you can add it back in there. And it provides a nice sane API to deal with that. So okay, we've got our bridge features back in there. And you say, well, what about parking? Like, all right, fine, parking. So now we're going to do something interesting. Parking is weird, because parking traditionally is just a location in the dial plan that maintains your state. but we'd have to use a masquerade to suck you out of there. So instead, we made a new bridge mixing technology called holding. And holding is just a very efficient bridge that can sit there and entertain any number of channels without them talking to each other. We just inject media. So plays music on hold, plays ringing, has a bunch of various other options. We then realized we also needed to do announcements, so you can also add a channel and they can be either a participant or an announcer in the holding bridge, and announcers broadcast their media off to everybody. So that works pretty well. Okay, so we have a new holding bridge. Parking decides to use the holding bridge. We rewrite all of parking, so all the parking code gets rewritten, and now we can get rid of all the masquerades that happen with parking as well. And so now the system gets a little bit larger. We now have a bridge holding mixing technology sitting over here that you get plugged into, and it's specific. It says, okay, I'm not going to participate when I'm getting chosen unless I know that you're going to be in there for parking. Or if you specifically say, please use the holding one. And you say, well, okay, well, that's great. What about my CDRs and my CEL records and my AMI and everything else? Okay, so version 5. Now we decided, how are we going to put this stuff back in? Used to all exist in the bridging code, but we really don't want to stick it back in there. So we're not going to put all of our CDR, CEL, and AMI code back into the bridging framework, because the bridging framework needs to be good at bridging and do nothing else. Instead, we're going to make use of yet another thing that we added into the architecture called Stasis, which jokingly stands for some thought actually spent in specification. I thought it was funny. So it's an internal pub/sub message bus is really all it is. And the bridging framework will publish state about the bridges onto the bus. The rest of Asterisk publishes its state onto the bus. And so now AMI, CDRs, CELs, and everything else you ever want to build on top of Asterisk can get the entire state of the system off of this bus to go build out new APIs. This is how we built ARI, by the way. ARI did not have new hooks placed in all over the place. It just listens to events and presents them as JSON over a WebSocket. So you have all sorts of options for doing this. So what does this look like? So in a very simplistic view, the bridging framework is sitting and talking to Stasis, and I've got AMI, CDR, and CEL that are all different subscribers to events coming out of the bridging framework. Let's say I pulled that channel out of the bridge. Well, pulling a channel out of the bridge is going to publish a new bridge snapshot onto the bus, which is just a limited view of that bridge, and is just enough for everybody to understand what happened in the bridge. AMI is going to interpret that in one particular way. It's going to raise a channel left bridge event. CDR is going to interpret that a particular way. It's going to update the state of the CDR, and assuming that the CDR was closed as a result of that, it's going to write the CDR out to the file, and CEL is going to possibly write the bridge exit event out to the database. They could drop them, just depends upon how it's configured or what it's supposed to do, but everybody actually gets their own interpretation of what this event means. And again, we didn't have to shove all that stuff back into the bridging code, which makes it much easier to maintain. And then you say, well, what about local channel optimization? Anybody know what that is? A few people raise their hands. Ule, I know, knows what local channel optimization is. Okay, so does anybody know what a local channel in Asterisk is? All right, so we're pretty good. So local channels are virtual channels inside Asterisk that is essentially bridges paths of communication inside of Asterisk. Local channel optimization is probably one of those things that seemed like a good idea at the time, but is probably something we could go back in time. We'd really wish we hadn't done it. It is the notion that if I have a real channel on one end and a real channel on the other end of a local channel, I don't really need that local channel anymore. That virtual path of communication is just wasting space and time because I have to keep passing frames and media along it. So I'm just going to get rid of it, and I nuke it out and I put things back together. It's really hard, as it turns out. So this is what it looks like, right? So ideally, we have foo and we have bar, and these are real PJ-SIP channels that are talking to endpoints. And they're sitting in a bridge with this local channel. And local channels always come in these little weird pairs that sit back and pass media back and forth. We're like, all right, well, how are we going to make this work now? So the first option is we do a bridge swap. And what we do here is we pick a winner between one of these two sides. And then we take one of the channels that is supposed to swap with whoever the winner is, and we simply take this local channel and put it into this bridge, and take this PJ-SIP channel and put it into the bridge this local channel was talking to, which creates this very weird little feedback loop for all of about a millisecond before it realizes that I should just die, and we kill it, and then it goes away. But okay, so this is the simple case, and this feels This was challenging, but we got it to work and everything was good, despite the fact that we have these bridge objects now and we have to do some work. But oh crap, I can also have this, right? Because now I allow any number of channels to go into a bridge. I can no longer assume that the bridge I'm looking at has only one other participant in it. All right, so now we had to make a new way of doing this, which was to do a bridge merge. And so when a bridge merge happens, we actually identify the two bridges that are going to be merged together, pick a winner, and then take all of the channels that are not the local channel and merge them all together. And then the local channel, who's now just dangling off into the ether, gets nuked and hung up. And that works. And by the way, we actually have a test in the Asterisk test suite that tests this with a 300 local channel chain. Because this is a very finicky operation and it's very easy to get it wrong when you think you're improving something. And that's our canary in the coal mine, that you might have broken something in the process of doing it. So that's great. But what happens if I have a conf bridge, which is built on top of this, and I use a local channel to try to merge two conf bridges together? Crap. Which is theoretically possible. I could take two conf bridges, which are technically using the bridging framework, put a local channel between them, and prior to a certain point in time, the code would have tried to merge these things together in the most horrific way possible, despite the fact that you've built policies on top of your conf bridge to say these are marked users or admins or everything else, and we would just be violating it. So when we analyzed the code, we realized that we've actually got 4 different places, at least, that have application logic that needs to be respected by the bridging framework. Conf bridge, which is the conferencing engine, which has marked users or admins or all these other different things. Parking, which needs to know which parking lot I'm in and some other properties of the parking system. ARI, which needs to know some very weird things about who's controlling the channel right now, either ARI or the Asterisk core. And then our replacement for Chan agent, which are the Chan agent waiting pools, which needs to know how long a queue agent has been waiting on a call inside of this special holding bridge that it uses. And so our solution to this was to give the bridge a class, essentially, with callbacks that allow the applications to update their state whenever we actually allow a merge or a swap operation to occur. As it turns out, conf bridge was such a pain in the butt that we just decided to prohibit it completely. You can't merge conf bridges together, which seems like a pretty safe thing to assume, because it'd be very weird that you actually had a valid use case for merging conf bridges. So with that change to the system, now my bridge object has a virtual table that includes methods. We have a basic implementation of that, and then we have concrete implementations for each one of these applications. And so at the end, what started with sort of a rather simplistic bridging framework turned into something much larger to actually accommodate all of the various possible use cases that somebody was going to throw at this. And it evolved to this, and I have current there with a little asterisk because things continue to change. People actually do continue to write new improvements for this. So there are new modules and things continue to get added. But it's become a very stable framework and a very solid foundation for handling everything from very simple use cases, two-party bridging, to the weirdest possible things that people can think of to throw at it. Like I have 300 local channels that I'm trying to merge 2 multi-party bridges at the same time. And I will say one last thing. There's some really fun things that you can do with this now because multi-party bridging is such a flexible concept. It's now possible in the core of Asterisk to converge an attended transfer into a 3-way call automatically. And then you could also let those people transfer that into parking or park the call and then pick it back up. And so it's hilarious whenever you blind transfer a multi-party call into voicemail, by the way, everybody trying to hit the digits at the same time, but whatever. Thank you. Anybody have any questions? Ask a question.
Well, is this on?
You have to add that.
Okay. As many of you know, I spent over 10 years doing development in Asterisk. At one point, I deep dived into zip transfers, which was totally wrong and messed up. I ended up in the masquerade code, tried to ask questions, realized I wouldn't get any answers on the mailing list. So I flew to Huntsville, met Mark and Kevin, and asked, what is this masquerade? And they basically told me, when you figure this out, please tell us. This is code that we all wanted to change for years. No one dared to touch or even try to understand. I'm really, really grateful for all the work, the 10 man-years you've done to fix this. Was an amazing challenge. I'm impressed that you've gone through it, and it's really taking Asterisk into a new generation. Thank you.
Thanks, Ule. And actually, I will say, actually, there were, the 10 man-years is actually probably a reasonable estimate because the first release came about a year and a couple months after we started the process. And there were a number of core Digium developers that worked on it almost consistently during that time, as well as a couple of people from the community who pitched in. And all told, it probably was about that long to re-architect that code. It was non-trivial.
I'm not very grateful. It's not sexy.
No, and hopefully very few people even knew we did it, right? Alex.
No, here.
Oh, I'm sorry, Tori.
You were talking about blind and attended transfer. I remember in previous versions of Asterisk, the call flow is a bit fake because you would always say the person answered well before the person actually did answer.
Yes.
So that could cause some failure transfer scenarios. Does the new bridging framework fix that, or is it still faked?
It is real, but that's also done in partnership with the PJ-SIP code. The Chan SIP is still fake. Okay. PJ-SIP, on the other hand, what it does is it actually attaches a frame hook onto the channel, which then listens for those events of the things leaving and joining the bridges, and then it generates the SIP notify requests appropriately during the transfer.
Alex.
I'm sure this has been considered, but you mentioned the pub sub bus. For high volume call setup, what are the contention implications of all the locking around it?
Initially, it was really bad. I'll go ahead and say that. We have done enough things at this point to improve the performance that for most high call volume setup scenarios, it's about the same as what you would have found in Asterisk 11. And really a large chunk of that was not just the locking, but being more judicious about what gets published out onto the bus. So the first cut of it, we were very liberal in what we were publishing, and that turned out to be a really bad idea. The other thing I will say is that because we have decoupled AMI, CDR, and CL off of the core code, if you don't use those things, you will get a bump in performance by simply turning them off, because it's one less subscriber to this stuff that now has to process the data. So that does actually get you a little bit of a net bonus too, that there may be a small penalty because now these things are passing through a message bus, but you also have the ability to disable the things you don't care about. Previously, in former versions of Asterisk, it would have called that code regardless. You may have disabled the CDRs, but it's going to still get into the engine for a little ways before it detects it. So
you're saying if there's no subscriber, then it won't be published a priori?
Pretty much no. I mean, the subscribers are done at runtime.
Question about the state change callbacks. Are those synchronous or asynchronous? And then are they called in a serial manner? Or
it actually depends on the subscriber. The subscribers have got several different mechanisms to determine what they want. They can determine if they get, there is a way to have it actually, excuse me, let me roll that back. Subscribers have a way to determine which threading model they want to be called on. They can either be called on a dedicated thread or they can be called on a dedicated thread pool that exists within the message bus. The publishers actually are the ones who control the synchronicity of it. So some publishers actually want it to be synchronized so that they know when all of the subscribers have received the callback. And so when you publish, you can say, please publish this, block me until you're done publishing this to the subscribers. Subscribers are always either on a thread pool or on a dedicated thread, depending on their subscription.
And for those state change callbacks, can those actually change the progression of the channel itself?
You could. I probably wouldn't recommend it. Generally, if you're on the message bus, it's because you're not interested necessarily in affecting the runtime aspects of things, but you're merely wanting to know what happened, and you're trying to sit outside of the channel progress. There's nothing that prevents a subscriber from going and requesting that channel, or even from a publisher from including a ref bumped version of that channel along with the payload, but that would probably be going slightly outside what I would recommend doing with it. I mean, if you really want to go impact the channel, just sit in the real-time aspects of things and don't give yourself the performance penalty of having to receive a message over the bus.
This is a quick one. When you change bridge types in a conf bridge, does that trigger a source change everywhere, or do you try to avoid that if possible?
Well, conf bridge luckily never changes its mixing type. So it's locked to soft mix because it says you're in a conference, so yea, verily, you must be multi-party. If you're not using conf bridge, but if you're doing like the normal two-party to multi-mix kinds of things, I would suspect off the cuff that we're probably egregiously conservative and hit a source change on it currently, but certainly you wouldn't necessarily have to. Somebody would have to go take a closer look at that. I'm guessing right now we probably just trigger a source change just to be safe. So, but yeah, it's not necessary though.
Okay, reminder that Asterisk and Digium are also present outside with some devices, and you can ask them questions, discuss with them more here. I don't want to keep Matt here under pressure with a lot of questions, as I could see there about Asterisk, so you can take your time outside. But yeah, as usual, thank you, Matt, really interesting. And who said that Asterisk cannot dispatch a lot of slides? Okay, so